Hello viewers, this is Major General Neeladra Kumar for the playlist Going Strong for the YouTube channel Lex Consilium Foundation. Today I am in conversation with Professor Paulraj. Now Professor Paulraj is one of the most illustrious scientists, engineers. He had his background with the Indian Navy, 25th NDA course, and he did his engineering from Lonavala, IIT Delhi. Gave him the doctorate he earned, and then after having served in the Navy from 1965 to 91, and during the course of that also he was undertaking projects. He worked for Sonar technology, and he set up 3 labs doing advanced work in the field of science and technology. Awarded a Padma Bhushan by the Government of India, and in his own field he's got the Prince Philip Award. These are the most prestigious award, Prince Philip Award, then the Faraday Medal and the Graham Bell Medal. Now my conversation today, I'm grateful to you for having given time out of your very busy short visit to India. We have heard about deep technology. Now, how is this term relevant in the Indian context?
Right. So, thank you, General Singh. It's an honor to, General Kumar, an honor to talk to you. And so, happy to share some views. So, as the General pointed out, I had a long career in India till the age of 47. And but I always had links with US universities, and so particularly with Stanford, where I'd done some teaching before when I was in the Navy. So I decided to go back to Stanford. So in 91, I went back to Stanford, and I've been there since then. For 10 years now, I kind of retired, but remain busy with a variety of things. So one of the issues that I like to convey to India, and always trying to do that, is the concept of deep technology. So these are the crown jewels of advanced economies of the United States, of China. China is at least in this area is doing well, but obviously the per capita GDP of US is higher. China is lower than that, but still 5 times ours. But certainly Japan and Europe in general. So the crown jewels are what we call as R&D intensive manufacturing with global reach. So things that almost everybody uses it, but extremely complex technologies. One example, which I'm sure we all know in India, is commercial jets. We tend to buy them from Boeing and from Boeing and Airbus. There are also 2 more jet suppliers, one from Brazil and one is from Canada, smaller ones. So these 4, the top 2 dominate the market, the other 2 do more smaller jets. So these are very, very complex systems. And it turns out at one point we probably had 300 companies building commercial jets, commercial aircraft, passenger aircraft, mostly propellers at that time. But the way the dynamics worked was it finally get consolidated into only 2 big giant systems. And today India is completely dependent on imports, so we don't add any value there. China was also dependent on import, but they have been trying very hard. Now they have a fairly well certified single aisle jet, and the double aisle is under trials. It's under a corporation called COMAC, which I have connections with. So that's the first important thing we all use in India, but we are dependent on imports. Other areas, electronics and semiconductors, from the cell phones and all the infrastructure which is connected to the cell phones, or your laptops, your PCs. Whenever you do your browse the internet, it goes to servers, and those servers have got a lot of computing in it. So internet, all this infrastructure in India is also imported. Those are also the crown jewels of countries like United States, China, a little bit in Japan, South Korea, who contribute to this. India has not yet contributed to it. The third, I would say, crown jewels is branded pharmaceuticals. That is, India is a good manufacturer of generic pharma, which is already out of patent and well known. But new molecules are discovered, are only done by this big company called Genentech, Merck, It takes a lot of money to discover those molecules, but when you discover them and they found to be useful, they can be charged very high. You can manufacture for $1, sell it for even $1,000 because people will pay for it because it cures cancer, does other things. So that whole sector of branded pharmaceuticals or patented pharma we don't have in India. And the third and the fourth area is advanced instrumentation. And it turns out a good example, not the only example, is instruments required, for example, to manufacture integrated circuits. There's a machine called lithography machine, which is smaller than a bus, that routine bus we see on Indian roads. And that machine costs $170 million. It's full of very advanced technologies. So those are also now coming into biotech, very advanced instrumentation. India does not participate. So these 4 or 5 areas, India is not a participant in it. So I want to talk. So I've been a little bit involved. Of course, my own career in the United States has been in wireless. So that's a part of this telecom part and semiconductors. I did 2 companies building wireless semiconductors in the United States, and I actually in '91 I kind of decoupled from India completely. But only in 2018, I began to get re-involved with India, and thanks to somebody called Aruna Sundararajan, who was Secretary of Telecom. So I chaired a committee for the government on 5G. And then I began to see how we were going about semiconductors in India. So I began to come to India many times, including meeting the Prime Minister, saying that this is a very, very important technology, semiconductors. There are 2 aspects of the industry. One is manufacturing, other is design. It turns out that the total value of this industry in terms of revenue is right now about 650 billion worldwide. And actually I would say it's growing very rapidly thanks to AI. So people say it'll double in 6 years, it'll triple in 10 years. So right now it's about 610 billion. Half of it is for design chips companies, and these are examples of NVIDIA, Qualcomm, Broadcom, mostly big names in the US. The US dominates in the design of chips. But in the manufacturing of chips, the dominant companies today are TSMC in Taiwan and Samsung in South Korea. So they are the top tier. The second tier is China and the United States. Intel was the only real company in India and US which makes it. Unfortunately, they're not at the leading edge now. They're kind of comparable to China. And China, of course, has about 45 labs, 45 fabs for manufacturing, and they have hundreds of companies doing chip design. So knowing China a bit, I was involved with them some years ago. I began to feel that we should also enter that market, and because semiconductors are so important, not only all the communications and devices we use, but is going to power AI. And in future cars, for example, people believe half the value of electric car will be in semiconductors, with so much of semiconductors. To, for example, a self-driving car, which is now being used in US pretty commonly, has huge amount of semiconductors for the AI, the self-driving problem. So these chips are coming everywhere, and they're coming to agriculture. It's so much a part of life, and India is 100% dependent on imports. And of course, it's also all these technologies are relevant to the defense, but I won't talk about that. So anyway, I had some thoughts about what India should do. My belief was that we had no background in that industry, so it's important for us to draw strengths from people who know it. And there are, of course, many Indians who in the United States, I'm a little bit a part of it, but there are many others, even better than me, who know the industry well and know not only the industry, all its dynamics and technology, but also how hard it is to enter. It's very hard to enter now, very difficult. So for India to enter, we have to take extraordinary measures to enter this technology. So that was my message back in 2019. But then I think a little bit later, we did launch the Indian Semiconductor Mission. That was a good thing. And it was launched, Mr. Vaishnav, the Honorable Minister for Electronics, runs it. and the MIT is the Department of Electronics is kind of it's housed there, and it has two pieces: the fab piece and the fabless piece. I'm kind of chairman of the fabless piece and a few more things in India related to semiconductors. On the fab side, manufacturing, I'm on the committee, but I'm not really involved with decision making. So India has now launched 3 or 4 projects. We have Tata Electronics, which is building a fab in partnership with a small Taiwanese company called PSMC, and that's coming up in Gujarat. They're also doing and that's called the front-end fab, where we diffuse the chips and make those diffuse wafers have the chips on them. But then you got to test those chips and package them. So that's called the back end. And then so Micron, which is a very large American company, is going to set up a packaging plant in Gujarat to do the back end packaging. And Tata is also doing back end in Assam. And there's 1 or 2 small investments. So we made a start, but we have to remember that the Tata Technologies and what we're doing, what Tata is doing, is actually it's at a node level which is much lower than the leading node. Leading nodes are very difficult to enter. I mean, those fabs themselves cost $35 billion each and requires an enormous amount of technical strengths. It's not good to go there first, and even the US can't touch Taiwan or South Korea. So we're starting in a modest way, but I'm sure Tatas will take it forward. So on the fabless side, one thing India can do is go and buy a large design company. We want to buy NVIDIA. Well, it's almost GDP of India, $3.5 trillion. We can't buy those things. Almost any company worthwhile to buy is hundreds of billions of dollars. So that's not the path for India. The other path, how these companies came, is startup. They grew from a small start and became giants. I myself did 2 companies, but I took the easy way out. Once they reached good production and sales, I sold them from one to Intel, one to Broadcom. But people who persisted, like Broadcom, started with 2 people, but now they have maybe 30,000 people all over the world, and they're a big supplier of semiconductors. So the way India has to enter the fabless side is now through the startups. So I'm deeply involved with that. Our ecosystem is now beginning of a very long journey. It's like we're trying to cover, I think, climb Mount Everest with tennis shoes and T-shirts. It's very hard. So my singular view of India is that we do have the raw talent. But we have to, be aware of all the hurdles in the industry. The industry is full of hurdles. Not only financing, for example, it turns out today, I know companies, I'm involved with companies which have raised $100 million, $500 million and are still struggling to survive. It's so difficult. So it's a very hard industry to enter for the level of skills involved, understanding the market, investments required, the talent that is needed, particularly seasoned talent, and intellectual property. This industry is full of litigation. If somebody tries to rise, you'll find that a company like Intel or a company like NVIDIA will have 50, 100,000 patents. So when you build a product, you're going to step on this patent and they will take you to court. So it's full of barriers. So my role in India really is to get the government to understand all these barriers. Only we understand the barriers, we have any chance of success in this industry. So I keep coming to Delhi every 2 years, every 2 months or so, 3 months, to persuade the government to pay attention to these barriers and to find and build an organization which is devoted to this industry, which can also, very importantly, tap into the knowledge of people who work in this industry, and there's nobody here in our country outside. So I think we have a lot of NRIs, for example, in the United States, who we can tap into. May not be hired them, but even as consultants, and a very short time to a very long time. And then, of course, bring in our own people, maybe from our administrative service. But in order to, we have to do many, many things. We have to, for example, find a way by which these companies that are being formed in India are mentored by people outside India who know the industry. Right now, these companies don't know the industry. So the chances of failure are very, very high. I would say in this industry, in China, I would say 99% fail. 1,000 companies have started, 99% going to fail. It's very difficult. But that 1% that survives and grows becomes giants. So we too will have to go that way. We'll find most of them will fail, but one will hopefully survive and become a global company. So we have to find mechanism to connect our baby companies to people who know the industry better. Then also, these companies are generally funded by venture capital. Venture capital are people who understand the industry, have the connections, and they put money in a few companies to try and build them up. And hopefully, the company becomes successful and they can make some profit. And in India, generally, there is a lot of venture capital for low-tech ideas. If you want to build a mall or a building, or even today, if you want to do something like an app, Ola, there is venture capital available. But you want to build semiconductors, nobody will fund it because it's very risky and takes too much money. So the government has to find a way of doing it, and I think there are mechanisms being discussed in the government as to how to. And also, I would say the venture capital that we need in India must come from the people who have done this before. So much of the venture capital who know the industry are sitting in the United States, China, a little bit in Taiwan, South Korea, maybe a very little bit in Europe. So we've got to tap that talent, tap that venture capital talent, and bring them and make it worthwhile for them to invest. Right now, they're not coming with this, and we can't make money. So we have to find how to make money. And there are mechanisms for that. I know the model in China and other models. So we've got to learn from the models and construct a scheme where we can bring that venture capital who have the industry knowledge to help our companies. That's the second one. Other one is, when does India succeed? I think today the total volume of the market is about 600 billion, I mentioned. In about 10 years from now, it will take at least 10 years to see any kind of results. The market will probably be around easily 1.2 trillion, maybe 1.5 trillion. So we want 1% of that market. We're talking about 1% of 5 trillion is something like 1 trillion is about $15 billion. $15 billion of value addition, $15 billion. And for semiconductor companies, $15 billion of value addition, that means total revenue minus cost of goods. So, and what we want is at least two companies will reach that level, and when that level, they're selling worldwide. They're headquartered in India, like Tata's are, but they have worldwide operations. So, both for sales and manufacturing and for design. Any big design company in chips has global operations. In fact, we host a lot of chip designers in India. We have 200,000 chip designers. In fact, people say 20% of chip designers in the world are sitting in India, but they're all foreign companies. There are no Indian companies there. So for us to rise, we need an Indian company or one or two Indian companies which are become global, certainly design things here, but we also have to have design abroad because these things are global. There's no such thing as make in India for India. If we try and build a company for chips for India, Indian market is so small the company cannot survive. It needs to have large volume to survive. So we need that. And also, this is a very litigious industry. Once we show some capability, we'll be sued. So many governments have policies to try and help these companies which are being growing there like little infants to protect them a little bit. And there are other measures that people have taken. I know the history in China and in Israel. So we need to evolve this, and so my role today is to be a humble servant of the Indian government, to tell them what I know, and I don't know everything, but to tell them that unless we really, really get serious about how to help these companies, our chances of success are very low. So we must, and of course, certainly in China, I would say in fabless, I think 95% fail. And that's fine. In the United States, in fact, the venture capital doesn't fund fabless anymore because they said they will not succeed. But they do fund in AI chips alone, and and even there, I think they'll be going to a lot of failures. So if you want to innovate something, there will be failures, and that's part of life. So India too will face that, but and we should understand that there will be failures, but we need to, out of that. All of this experience we built, we want to have one or two companies which are global. So it's going to take 10, 15 years. I know the Prime Minister knows this. So we're going to take a lot of perseverance, a lot of patience to bring this forward. We're now starting at the very beginning of a long, difficult journey. And so my little role in India, I work in the US and I'm very much there. I do come here often, and quite often I'm on these meetings. I do it on Zoom calls with the Indian government. But I'm totally convinced that India can do it. We have done good things. It's possible. And also an important thing here is you can only enter this industry by having a new piece of a new IP, a new idea, a new invention. So you cannot enter saying, Mr. NVIDIA is doing that, I'll do the same thing, because you try and catch up, within 5 years you get a product, they're gone far ahead. So you've got to have a new innovation. So it's important also to bring up our university system so they can contribute innovation ideas which we can commercialize. So both at the level of innovation from universities, then the design industry where people know how to design chips. Quite often we need a lot of PhDs. I think in my first company I had about 240 engineers, maybe about 80 were PhDs. So these are very heavily complex systems. And then we need manufacturing. So I think we're starting on a long journey. My only thing to message to India is it's very hard. So unless we understand how hard it is, we cannot succeed. That's my single message. So I'll hand it
thanks,
back
Professor. It is remarkable because you have given the complete sort of blueprint, the way ahead, and the difficulties trying to climb the Everest with tennis shoes. Fine.